Okay, let's get started. So last day we were talking about regular expressions. And it's not just the bash shell that uses regular expressions. So there's a whole bunch of programs in Linux or Unix that understand regular expressions. Because a lot of the things that you do in Unix or Linux is it's either text-based or it's file-based, right? And so there's a lot of searching strings, searching text for patterns. Grep is one of those programs. So grep stands for Global Regular Expression Print. And basically what grep will do is it will search a file or files or standard input if you don't give it any files for lines that match a regular expression, right? So you can search very, very, very large text files for stuff in the files, right? Now grep by default uses the POSIX basic regular expressions, right? And we've been talking about the extended regular expressions. So if you want to use the extended regular expressions, you should use -E to tell grep to use the extended expressions. Okay? So for our purposes, I'm always going to be writing -E. Now there is many of your computers will have a program called egrep. I don't know if Mac has it, but Linux definitely has it. Egrep automatically sticks in the -E for you. So egrep is extended regular expressions, right? So if you want to, you can use egrep. I'm pretty sure it's on CASLab. It's on most Linux distributions and Linux and Unix distributions. If you read the official documentation, it says it's deprecated, so in the future it may go away. But that's probably not going to happen anytime soon. So grep's just a command. So you can feed it some options, look at the man page for the options. There's a whole bunch of them, right? So you'll have to look at the man pages for them. You give it some regular expression, right? And then you give it one or more files in which to search for lines that match the regular expression. Okay, so for example, it'll also read standard input if you don't give it any files, right? So for example, I can list the contents of user bin, right? I can pipe the results to grep, right? And I can look for any line that matches the word zip, right? So that will find any program that contains the word zip in it, and we can try that. Right, so root user bin. Why did I use user bin? It doesn't matter. Pipe grep minus. I guess we should use -E. It doesn't matter in this case. You get the same result either way, right? And you get that. So there's every program in the directory user bin that contains the word zip in it, right? So I don't have any of the anchors, right? So I'm not matching the beginning or end of the line. So now I'm just looking for words that contain zip, right? And you can see there's a bunch of zip programs here. Right, gzip and gunzip, those are the Linux commands for zipping and unzipping a file. Right, the G stands for GNU. If you want to, you can use the anchors, right? So I can try to find every line that starts with zip. Right, you probably don't need to see all these, but anyway, let's do it. Right, any line that starts with zip, so you only find zip details. Right, any line that ends with zip. And you'll find the gunzip, gzip, and gpgzip programs, right? Okay, grep's not super, I mean, sure, it's useful for doing that sort of thing. But really where grep is useful is when you want to search files. There's an error on this file if you've got it from the website. The extensions are wrong on the files, right? So if you want to search a source code file, like a Java file, right? For all the lines that contain a for loop, you could write something like this, right? So grep -E n will give you the line number, because you probably want to know the line number, right? If you're looking for the word for, right? And then you can feed in one or more Java files here, right? So this is the CISC220 assignment 2 file, which I can't show you, right? And so that will list every line that contains a for in it, right? Which will basically give you every line that has a for loop. Unfortunately, it gives you more than that, right? It gives you every line that has a for in it, right? So not necessarily a for loop, but if you have a comment or a variable that happens to have the word FOR in it, it will find those lines too. Right? So you can be more precise in your regular expression matching. Right? I can look for the word for, right? Followed by, now this is using a POSIX character class. Right? So this is the character classes of blanks, which are basically spaces and tabs, I think. Right? So that'll match a space or a tab. Right? And then I have star, right? 0 or more. Right? So for followed by 0 or more spaces, followed by the opening round bracket, because you always need an opening round bracket in Java, right? In a for loop. Right? Now, the bracket is important, or the bracket has special meaning in a regular expression. Right? So you have to escape it. That's what the backslash is for. Right? So that basically reads, look for any line that has a for, followed by 0 or more spaces, followed by an opening round bracket. Right? And that will get you your for loops. Right? It might find other stuff, but the other stuff it finds would be a little weird. Right? It'd have to be something with for, then a round bracket. Right? But that would be a little bit unusual. All right. Now, it's also useful for searching HTML documents for tags. Right? I don't know how many of you know HTML, but in HTML, I guess important features in the document contain what are called tags. Right? The tag always begins with a less than sign, and then there's something in it. Right? So if you want to find all the anchor tags, you can search an HTML document using that regular expression. Right? And that will find all the lines that contain an anchor tag. Right? The space is important here. Right? Because if you don't put the space in, then you'll get any tag that starts with an A. Right? This one will actually find any tag that's an anchor. Right? So there's another example. Oops, sorry. What just happened? That was weird. All right. OK. If you have the spell program installed on your version of Linux or on your Mac, actually, I'm not sure where Mac stores its dictionary file. I'm not sure if it's here or not. But in Linux, Linux will store your dictionary files in this folder directory called user share dict. Right? So I've installed the spell program. If you're using Windows, you're using the Linux subsystem for Windows, just type spell and then press enter, and then it'll tell you the command to install spell if you don't have it already. So I've got I have a big dictionary file there. It's just a plain text file with one word on each line, right? So if I want help solving a crossword puzzle, so I'm looking for a word that's 1, 2, 3, 4, 5 letters long, right? 5 letters long. It starts with something that I don't know, followed by an A, followed by a K, followed by something I don't know, followed by an S, right? You can do it this way. So let's try this. Now, unfortunately, I have to type this in because of this copying and pasting issue from PowerPoint. So bear with me for a second. So I'm going to grep minus EI, right? Starts with something I don't know, followed by AK, followed by something, followed by an S. Right? So in user share, there we go. Right? And that's not right. I forgot the closing anchor, sorry. You see how important the anchors are, right? If you don't include the anchors, then it matches everything. OK, and there you go. So there's every word in this particular dictionary that starts with some letter, is followed by an A, a K, followed by some letter, and then ends in an S. Right? So if any of you like playing crosswords and you like to cheat, go ahead and do that. Right? Right. So I didn't. So when you're writing conditions in Bash, you are allowed to combine them. Right? So there are logical operators to combine stuff. You've been programming a long time now, so I don't think I have to really show you a whole bunch of examples here. If you're using the double brace, the double square bracket or the double round bracket condition, right? You can use double ampersand, double bar, or not, right? So the same things you use in Java, right? If you're going to use the double square brackets or the double round brackets. If you're using the single square brackets, right, which is still very common, and is minus A, or is minus O, and not is the exclamation mark, right? So you can combine logical expressions this way. This slide is blank because I forgot to fill it in, so we'll ignore that for now. Sorry about that. Okay, reading keyboard input, right? Okay, so there's if you want to read keyboard input for your script, right, instead of grabbing stuff from the command line, or in addition to grabbing stuff from, instead of grabbing command line inputs from standard input, instead of grabbing command line inputs from the command line, command line arguments, right? Okay, you can also prompt the user for input using read, right? So read's one of these shell built-in commands, right? So it's part of the bash shell itself. And it reads a line from standard input and splits the line into fields. So it does the splitting for you, which is really nice, right? Now remember, it's a built-in command, so you can't do man read. You have to do help. So let's take a quick look at that. So help read, and you see it spits out, it's not too long actually, so that's nice. Back here. Okay. Okay, so what does read do? Right, it says read, a whole bunch of options, right, blah, 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 blah. But it reads a line from standard input, splits it into fields, right? So it reads a single line from standard input, or it will read from a file descriptor if you want to, right? And the line is split into fields, as with word splitting, right? So we know that with word splitting, bash tends to split strings at spaces, right? Spaces, tabs, or new lines, right? But it tells you a little bit more information here, right? So the first word is assigned to the first name, right? So you're supposed to feed it some names as well. The second word is assigned to the second name, and so on. Any leftover words are assigned to the last name, right? So I'll show you an example of that, right? And how does it split? Well, it says it uses the characters found in this variable here, right? So capital IFS, right, is the variable that stores what characters to split on. And so that'll be useful in a second, right? And it tells you if no names are supplied, the line is read and stored in the reply variable. Right? So it also tells you it'll make a variable for you to store the results if you don't give it one. And then there's a bunch of options, which you can read later, right? Okay, so that looks like it could be useful for some things, right? So here's our isEven program again, right? So remember with isEven, if we gave it no arguments before, then it would it would exit with 1, right? So if you write isEven4, I guess, .sh and press enter, I guess we can do that. Boom. Right, so isEven4, press enter, echo, right? It tells you the number 2, right? So it fails. There's a failure, it's not even, and there's a failure code of 2, or an exit status code of 2, right? With isEven5, oops, sorry. If I give it no arguments, it now prompts me for a number, right? So I can now give it a number, 4, right? And then look at the result, 0, right? So apparently 4 is even. And how does this work? Well, we use read, right? So if there's no input arguments, then read. -p will print the prompt, right? So that's the prompt that you get if you use -p, right? If you don't use -p, it won't print anything. It'll just have a blank line, and you'll have to type stuff in, right? So if you don't use a prompt, you have to print the prompt before you call read, right? And then after, at the end, is a list of names, right? Just a list of variable names. So here I've got one, right? I've got one name called val, right? So that makes my variable val for me, right? And read will store the results of whatever you type into the command line into val, right? So if I have no arguments, prompt the user. Otherwise, grab the first value, the first command line argument, right? And then go ahead and do your checking for whether or not val is even or odd. Right? So there's one example of using read. Right? Now read will read into multiple variables, right? So as many variables as you want, right? Read will read into those variables. Right? So here it's called read3. Right? This will read up to 3 arguments from standard input. That's not quite true. It will read more. But you'll see what it does with the extras in a second. Right? So again, I'm going to prompt the user, right? Enter 1 or more values. You can actually enter 0. It will work, right? And then it's going to store the first, I guess, word in var1. It'll store the second word in var2. And it'll store everything else in var3. Okay? And if you give it nothing, well, it doesn't fail, which is pretty different than the programming you're used to. Right, so this is read 3, right? So enter one or more values. So let's do ABC, X, Y, Z, and oops, sorry, and 1, 2, 3, right? And then it prints out var1 is ABC, right? var2 is X, Y, Z, and var3 is 1, 2, 3, right? So it splits the input, right? Using the, in this case, white space characters, and then stores each field into the corresponding variable. Right? If you give it just one value, right, it does not fail. It actually works. Right? So it stores ABC into the first variable, so var1, and then the remaining variables are all empty or unassigned. I believe they're unassigned, so they're actually null. And if you give it too many, right? So A, B, C, D, E, F, G, right? That's more than 3, right? Then the first 2 go into var1 and var2, and everything else goes into var3, right? Okay, and now read will also read into an array, right? So having everything else go into the last variable is sometimes inconvenient, right? If you want to get everything from read, then you should read it into an array. Now, we haven't talked about arrays yet, but we will, probably in the next lecture, right? So for now, you'll just have to ignore this somewhat strange syntax that follows the read statement, okay? So once more, I'm going to read using a prompt, right? So enter one or more values, minus A, right, followed by an array name will read into the array. Right, so minus A, ARR, will read into that array. Now, you don't have to worry about arrays having fixed size or anything like that. Right? So unlike Java, arrays do not have fixed sizes in, arrays do not have a fixed size in Bash. Right? And you don't have to do anything special to make the variable an array in this case. Right? Read will create the variable ARR for you and treat it as though it were an array. Right? And now you can see the array syntax is kind of gross in Bash, right? The number of values in the array you get by doing this weird pound array at thing, right? That's just the way Bash is, right? Here we've got a for loop, which we'll look at in a few minutes, I guess, 15 minutes or so, right? And notice that you use the square brackets for indexing, right? So just like Python and Java, it's square brackets for array indexing, right? Arrays normally start at 0. Are normally indexed starting from 0. Although it's Bash, so not necessarily, right? Okay. So, oh wait, we should run that program. Let's back up, right? So here's read n. Right, so enter one or more values. So let's do A, B, C, D, E, F, G, H, I, J, and K, right? So lots of values. And you can see that it populates the array with each word going into a separate element of the array, right? In order, right? In order. So that's how you read something where you want to grab every individual word from the input. Okay. Now, what if you don't want to split on spaces? So so the read documentation alludes to that there being a variable called IFS, all caps, right? Word splitting is performed using white space by default as your separators, right? So any one or more white space characters between letters will be treated as a separator by default, right? That variable IFS is called the internal field separator characters. Right? So that's what it uses to do the splitting. Right? So by default, the space is considered a field separator, the tab is considered a field separator, and the new line character is considered a field separator. Right? So those will all separate fields when Bash does word splitting. Right? But you can change that, right? It's just a variable, so you can actually change it. Now, it's a fairly important environment variable, right? So every program is going to use IFS to do the splitting, right? So if you change IFS, you have to change it back to the default, right? Otherwise, every other program that you run is going to use the new version of IFS to do the splitting, right? So IFS is an environment variable, which means everything in your shell can see it. OK, so remember path. We had this variable called path a while ago, right? So if I echo my variable called path, right, you get this mess, right? So remember, path is just the list of directories that Bash uses to search for executable programs, right? The separator is the colon, right? So if I wanted to print this in a way that's easy to read, so for example, one directory per line, right, then I want to split on the colons instead of the spaces, right? So I can do that, right? I just change IFS to be equal to the colon, right? So, but remember, if you're going to change IFS, you have to set it back, right? So you remember what the IFS currently is, right? So I've got a variable called old IFS, right? And that saves the current list of field separators, right? Then I go ahead and change IFS, because that's what Bash is going to use to do the word splitting, right? So now I tell Bash I want to use the colon, right? Then I read into an array ARR everything from the path, right? So here we haven't seen this triple less than sign yet. I'll explain that in a minute, right? And then after I'm done reading, right, using the colon as the splitter, as the splitting character, right, I reset IFS back to its original value, right? And then you go ahead and print out everything one per line. I don't know if I have this on my computer. So this is print, sorry. Oh, it does work. OK, good. So if I run that program, right, it gives you that, right? So it takes my path, splits up all the directories, and stores each one in an array, right? This is Windows, so it's a little weird, right, because it's using the Linux subsystem. All of these things that are /mount_c or something like that, those are your environment variables from Windows, not from Linux, right? So you can see there's stuff like Windows program files, blah, 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 right? OK. So the syntax, that triple less than sign, is using what's called a here string, right? So read -a ARR less than $path, right? That less than $path is called a here string, right? And so what's happening is, so remember, read normally reads from standard input, right? So what I'm doing here is I'm redirecting that variable, right, to the standard input for read, right? So path gets expanded, right, and fed to the standard input of the command on the left-hand side of that triple less than operator, right? So whatever's in path gets fed to the standard input of the read command in this case, right? OK, so here's an example of using that triple less than sign again, right? So you could, so here we're looking for anything that matches txt, OK? And we're using an if statement. So this is a little bit weird. So remember how if statements work, right? If some command, right? So echo var is going to be our command, right? If that command returns 0, it will do if echo right. If that command returns 0, it's going to go into here, right? It'll go into grep, right? So this is the same thing using a brain fart. Sorry, using the here string, right? So I'm going to take whatever value is stored in var, and I'm going to feed it to grep. Right? So I'm going to feed it to the standard input of grep, right? Grep's going to look for anything that matches txt, right? And then it will echo var contains the substring sequence txt, right? Now what does a -q do, right? So remember what grep does when you run grep, right? It actually spits out any matches, right? So it prints out the matches. -q means quiet, so do not print out the matches, right? Simply return 0 or non-zero, right? Return 0 if there's a match, right? Return non-zero if there's not a match, right? And so if you run this, you can get it with some variable called var, right? You can get it to spit out. You can get it to spit out whether or not it contains the sequence or not, right? But there's another example of a here string. I think there's one more. Yeah, here's another one. Right, so here's another example of a here string with read, right? Again, it's going to read into an array, right? So take the contents of string, right? So this is a string of words, right? It's got a bunch of white space in it, right? Take that, feed it into standard input of read, right? Read's going to take whatever you feed into it and split it into an array, right? So the first word is going to be stored in word 0, right? And that's going to be this, right? The second one will be in words 1, and it'll be is, then a string of words, right? There's nothing at the end, so the last thing in the array is going to be null or empty, right? Okay, now you might ask yourself, why not use a pipe instead? Because I've told you about pipes, right? So why don't I just pipe, take echo string, right? Because echo string will print something to standard output, right? And then why don't I just pipe it into read, right? Instead of using a here string. So why do I have to use this bizarre syntax here instead of just doing what we had before, right? So in other words, why can't I write echo string pipe read var1, var2, var3, right? Because that's what a pipe's for, right? You want to take the output from this command and send it to the input of this command, right? Now, unfortunately, it works, but it doesn't do what you want, right? And that's because of the way pipelines work in Bash, right? So when you have a command here and you pipe the command into something else, right? That command there, the read command, runs in what's called a subshell, right? So it doesn't run in the current shell. It runs in a subshell because it's part of a pipeline, right? So a subshell is just a copy of your current shell plus all the environment variables that your current shell has, right? So it spawns a subshell, and it runs read in that subshell, right? Read does exactly what it's supposed to do, right? It takes the first word in string, sticks it in var1, takes the second word in string, sticks it in var2, takes everything else, sticks it in var3, right? But var1, var2, and var3 are variables in the subshell. They're not variables in the current shell, right? When the command completes, the subshell is destroyed. So var1, var2, and var3 go away along with everything else that was used to run read, right? So they exist in the subshell, but then they go away and they don't come back to the shell that where you started everything, right? And so that's why it doesn't work, which is why you have to do something else to get the input into read, right? And so that's why you have to use that here string, right, instead of a pipe. Okay, I forgot to copy this file onto this computer. It's at home on my other computer. It's not on this one, so I can't show you this. I'll have to give you the. I'll have to post the script for you guys to read. Basically, this is just making a menu. So it's giving you a program. It prints out press 0 to do something, press 1 to do something, press 2 to right, and then you read in. You use read to read in the user's choice, and then the program decides what to do based on the choice. Right, it's a fairly long script, and unfortunately, I forgot to put it on here. Okay, so what do we got so far? So we've done regular expressions, right? We looked at grep. We've done reading in user input, right? And there's not much left to do, right? So there's basically, we've done arithmetic as well, right? So all we've got left are loops. Right? So how do you loop over stuff? And we've got arrays, and then there's a few little odds and ends. And that's basically it for Bash scripting. So the loops. Bash has 3 kinds of loops, right? So there's a while, right? While runs as long as some test command has an exit status of 0, right? So you know a regular while loop in Java runs as long as some condition is true, right? Bash is weird. It uses commands, right? It uses the exit status of commands. So while runs as long as the exit status of some command is 0, right? that means it runs 0 or more times, right? If the exit command, if the first time you run that command is not 0, right, it won't run. The loop body won't run. Until is like a do while loop in Java, right? So until runs as long as a test command has an exit status of non-0, right? And that means it runs 1 or more times, right? Is that true? Runs as long as the test command? No, that's still 0. That's the second bug in these slides. Sorry, that still runs 0 or more times, which is not like the do while loop in Java. Sorry, so I misspoke there too. So I'll show you an example of that in a second. And for, there's 2 versions of for, just like there's 2 versions of for in Java, right? So there's a version of for that looks like a for each loop, right? That runs once for every string in a list, right? And then there's a version of for that looks like the traditional C or Java for loop, right? For int I equals blah, 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 blah. OK, what does the while loop look like? So remember, Bash uses command, the exit status of commands, right, for the conditions. So while uses the exit status of a command for its condition, right? So while that command returns 0, has an exit status of 0, right? Do these commands, and then you're done, right? So done marks the end of the body of the while loop. So to count to 0, starting from 10, right? Start with the variable count. It's equal to 10, right? If you want to, you can get that value from standard input from command line argument instead, right? Or you can get it from read, right? Then we have while, right? Now remember while, then there's followed by a condition, right? So here I'm going to use an arithmetic condition, right? Because this one looks more like what we're used to looking at, right? So while the count is not equal to 0, spaces are unimportant inside the double round brackets. There should be a space here, right? So while the count is not equal to 0, so do marks the beginning of the loop body, right? So we just echo the count, right? And then you want to decrement the count by 1, right? So here I'm using an arithmetic expression again to decrement the count. What you have to remember is inside these arithmetic expressions, right? Bash knows what the variable is in an arithmetic expression, right? So you do not put the $sign in front when you use the arithmetic expression, right? So you can write just the variable count instead of $count here, right? Similarly, you don't have to quote it or anything else, right? The double round bracket suppresses the white space breaking, word breaking, right? And then done. So that will just go 10, 9, 8, 7, 6, right? I don't think it's worth running. It's not the most exciting program in the world, right? If you want to, right, you can use an arithmetic expansion instead, right? Arithmetic expression, here it's an arithmetic expansion, right? So if you're going to do variable assignment, right, and you want to compute count minus 1, that's fine. You can do them in the round brackets, right? But to get that answer out, you need the $sign. Right? So there's an arithmetic expansion, right, which is different than an arithmetic expression. Okay? You can write them either way. It doesn't matter. Yes?
Arithmetic expressions?
Yeah.
What are the exit codes?
Oh, the exit codes are different. Remember, so if that evaluates to 0, it's true. Yeah. So it's the other way around. Yeah. Right? So you can write them either way. It doesn't matter. You can write that if you like, which is probably easier. You could write it like that if you'd like to do the assignment instead, right? But if you write it like this, you need that $sign in front. OK. Oh, here's the Collatz conjecture, which I also should have saved as a script. So again, I can't copy and paste this in because it won't work. When you copy and paste it in, some character gets translated incorrectly, and Bash gets confused. I don't know if you can read it. Can you actually read it at the back? Yes, hopefully. OK, this is the Collatz conjecture, which I don't know if you've seen. Who's seen the Collatz conjecture before? A few of you? OK, so the Collatz conjecture says, start with some positive integer value, right? If the integer value is even, divide it by 2, right? If the value is odd, multiply it by 3 and add 1. and repeat until the number reaches 1. Right? Repeat until the number reaches 1. The Collatz conjecture says you will always reach 1 regardless of the number you start at. Right? And so this is naturally expressed as a while loop. Right? So all this stuff up here is just getting a value. Right? So there's a bunch of input. There's a get the value here with read. Right? Check if the value is an integer here. Right? Check if the value is less than 1 here. Right? If it's less than 1, we're going to exit with an error code. If the value is not an integer, we'll exit with an error code. Right? And then here, we're just going to write a little while loop. Right? So while my value is not equal to 1, right? Do the following. Right? If the value is even, so in other words, can you divide it by 2 and have no remainder? Right? Then set the value to value divided by 2. Right? Again, notice right there, that's an arithmetic expansion. Right? So that's assignment into a variable. Right? I need the arithmetic expansion here to compute the value. Right? So if it's even, do that. Otherwise, multiply it by 3, add 1, and stick it back into val. Right? And then we print val every time. Right? If you start this program with 27, you get a surprising number of lines of output. Right? As far as anybody knows, the conjecture is true, but no one has proven it to be true thus far, despite many, many, many years of research. Right? No one knows if this conjecture is true. But they've written computer programs to test huge numbers of n, and as far as anybody can tell, it appears to be true. Right? So you'll always reach 1 if you start with a positive integer value. So it seems. OK, the until loop. So that should be 0. I have to fix that too. So the syntax of the until loop is until that command is false, right? Do the commands. Right? Right? So do and done, those mark the beginning and the end of the loop body. Right? So if I want to count down to 0 starting from 10, right, I can just check until the count is less than 0. Right? Do this stuff here. Right? So it's just a different way of expressing your condition. Yes?
Why does that implement? Like, it seems like everything that does you can do with a while.
Yeah, you can. Sometimes it's more natural to express the condition this way, right? That's it. The loop, it's just a different way to express the loop. But yes, you can do the exact same thing. I mean, you could write everything with a for loop too if you wanted to, right? So it's just another way of writing a loop, right? Now the for loop. So the for loop, like I said, there's 2 versions of the for loop, right? This is the for each version. This is Bash's version of for each. Right? So this is Bash's version of what you guys learned a Python loop to be. So the syntax is for some variable name in some list of words, right? Do some commands. Right? So that runs once for each string in the list of words. Right? In that list of words. Now a list in Python and Bash, sorry, is just the words with spaces between them. That's it. Right? There's nothing special about a list in Bash. Right? And each time through the loop, name takes on one of the words in words. One of the words in words. Yeah, that's right. Right? In sequence. Right? So if you want to, here, this loops over the strings A, B, C. Right? So for I in, so that's a list in Bash. Right? A, B, C. Right? All I'm going to do is echo out the value of the loop variable. Right? So that'll just print out A, then B, then C. Right? Each time through the loop, I takes on one value in the list. Right, so that pretty much looks like a for each loop. Right? This one loops over the file names. So the interesting thing about this is that list does not have to come from a variable. Right? Anything that produces a list of words in Bash is suitable here. So here you can use a file name expansion. Right? So if I go into the bin directory and I write for I in Z star, right? What does Z star match? It matches every file name that begins with a Z, right? So for every file name that begins with a Z, echo out the file name. Right? So we can try that and see if it actually works. So I'm already in bin. Right? So for I in, Z star, echo $I. I guess I should quote that in case there's any file names with spaces in it. For I and Z star, echo I done, right? Yeah. Right? Oh, sorry. Ooh. So that's what I'm missing. Yes, thank you. Do. And, oh, wait, am I in the right directory? ls. Oh, sorry. Oh, no, I'm in the wrong, okay, here. I'm in the my bin directory. There we go. Okay, so for I in Z star, do echo I done, right? So that prints out every file that begins with a Z. Right? So any expansion that gives you a list is suitable for the target of a for loop. Right? Now, oh yeah, I should show you that too. Now there's a problem with this. Right? So the problem is, what if there's no match? Right? So I don't have any files called Z that start with ZZ in this directory. So the question is what does this loop do? Right? Does it actually run? The answer is it runs once. Right? So if it can't match anything in ZZ, if it can't find a file name expansion that matches ZZ star, it uses ZZ star as the list of strings. Right? And so you end up with ZZ star. So if you're going to do something like this, it's important that you check, right? Is there actually a file that begins, that's named ZZ star, right? Because you probably don't want the loop to do something like this, right? You want to do something for every file that begins with Z star, right? Or for every file that matches the file name expansion, right? And you don't want it to do something with just just that literal ZZ star, right? So you have to do something like check, right? So remember -e? Does that file exist, right? If it doesn't, so ZZ star does not exist in that directory, right? So you'll skip over the if and then come out of the loop, right? If it does exist, though, then you do something with it, right? So you have to be a little bit careful here, right? If that expansion doesn't match anything, then you end up with whatever that expansion is as the list of strings. Okay, the second for loop is basically the Java style for loop, right? So in Java, you would write for int I equals 0, I is less than something, I plus plus, right? This is the exact same thing, except now you use the arithmetic expression, so the double round brackets, right? And that should be very familiar to you, right? So that's reading for I is 0, I is less than or equal to 10, I plus plus, right? So that'll go from 0, count up to 10 from 0, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So there shouldn't be, I mean, if you want to write a loop, if you want to write a for loop, that's probably the version of the loop you want to write, right? In many cases. It's either this one or this one, right? Where you want to loop over the values in a list, right? So the easiest way to think about this, I think, for you guys would be this is for each, and that's just a regular for. Of course, you can count down to 0, starting from 10, right? Good. Any questions? Any questions? Super. I guess, so you will have an assignment 2 that was supposed to come out earlier in the week, but it's going to come out tomorrow. And I'm probably going to shift the assignment due dates to account for the fact that this one's coming out so late. All right, but it will come out this week. Sorry?
I think we're going to have to write the bash. I'm assuming that's what he said. We're going to have to write a bash script.
Yeah, you're going to have to write some scripts.